Hi guys, Miss Powell here. Today we're going to finish up our lesson that we started yesterday on normal distribution. All right, so first of all, the first question that we see here is what is the probability that a woman in this college would have a height less than 71 inches? So if we refer back to yesterday's lesson, specifically talking about example 4 says the heights of 3,000 women at a particular college are normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. So if I ask you the question of what is the probability that a woman in this college would have a height less than 71 inches, we have a problem here, right? Because 71 inches does absolutely not fall on one of our standard deviations, right? It's actually in between our standard deviations noted at the 70 and 72 mark. So when this is the case, we have to use a formula called the cumulative density function, or as your calculator refers to it, as the normal CDF. So we have three different functions for the normal CDF. The first one is for when x is less than or equal to a k value. The middle one is when x is greater than or equal to a k value. And the last one is when x is limited in between two values. All right, so our question here says, what is the probability that a woman in this college would have a height less than 71 inches? Well, obviously that's going to go with that top formula for the probability of x being less than or equal to k. So how do we use our calculator to do this? Well, I'm glad you asked. I went ahead and made a screenshot of all my keystrokes using the TI-84 Plus here. So that you guys can follow along, or if you need to refer back to this at some point, you can do that. So the first thing that we want to do is obviously clear your screen. Hit your second vars, number 2. And what you'll see right away pull up, it says normal CDF, lower is -1 e to the 99, right? So that's the general default on your TI-84 calculator. What that is it's a number that's extremely tiny, close to 0, but not quite at 0, but super, super close to 0, okay? So when we are looking at when x is less than or equal to a k value, that's what we want to go ahead and put into our lower quadrant, okay? So if it's not already there yet, though, you're going to put negative, not minus, -1, and then your second comma button, which is the double E, that's what pulls up that big E, and then 99. Hit enter, and we're going to input our upper value, right? So that's where we are stopping. In this case, we want to know how many are less than 71. So 71 goes into that upper. The next thing that we want to look at is our average, right? So what is our average height? Our average height here is, what did we say it was? 65. And then we want to go ahead and input our standard deviation, which is 2.5, hit enter, enter, and then enter one more time. And what you end up seeing is that 0.9918 is our probability that the woman in this college will be less than 71 inches, which makes sense. Less than or equal to, I should say, 71 inches. Why is that? Because the closer this gets to 1, the closer this number gets to 1, the closer we are to having all of our people accounted for, right? So 72 inches is technically 6 feet, right? Which is pretty tall for a woman. Most women are less than that. So almost all of our women are going to be 71 inches or less. All right, so let's look at our next example. Our next example here is number 5. It says, a particular leg bone for a dinosaur fossil has a mean length of 5 feet with a standard deviation of 3 inches. What is the probability that a leg bone is less than 62 inches? All right, so you can see right away, right? We're looking at less than 62 inches. So that goes with our top formula, the formula that we just used before, but I want you to be very careful here. We have a couple different units of measure. We see that it has a mean length of 5 feet with a standard deviation of 3 inches, but we want to know what's the probability that a leg bone is less than 62 inches. So before you can even begin this problem, really everything needs to be in the same unit of measure. So you need to go ahead and convert that 5 feet to inches. So 5 feet times 12 inches is going to give us 60 inches total, okay? So now let's go to your calculator. Once again, you're going to clear your screen out. Hit your second vars, number 2. My calculator automatically pulled up -1E99, which is good. If it didn't, I'm going to put that in myself. Go down to your upper bound. Your upper bound number here is 62, right? That's where we're stopping. We want to know less than or equal to 62. Our mean here is 60 inches, with a standard deviation of 3. Hit enter a couple times, and we end up with the probability of 0.7475 that the leg bone is going to be less than 62 inches. Okay, as I said before, if you're having a hard time following me verbally, then I've laid out every single step here in the keystrokes, and you can see what to do. All right, looking at our next example. With our next example, it says the weight of chocolate bars from a particular chocolate factory has a mean of 8 ounces with a standard deviation of, this should actually be 0.1 ounce. It's hard to tell right here because this point is up here, but it's 0.1 ounce, just FYI. What is the percent that a randomly selected bar is between 7.85 and 8.15 ounces? Okay, so here we actually have a different lower bound and an upper bound number, right? We want to know between here and here. So since that's the case, we're going to go ahead and put this into our calculator. So hit second vars 2. Okay, our lower bound number here is 7.85. So we're going to put in 7.85, hit enter. Our upper bound here is 8.15. So 8.15, hit enter. Our mean here is 8 ounces, so 8, enter, with a standard deviation of 0.1, enter, and then enter 2 more times. And what we end up seeing is we get 0.8664 as our probability that a randomly selected bar is between 7.85 and 8.15 ounces. All right, so let's look at example number 7. So the grades on a statistics midterm exam are normally distributed with a mean of 72 and a standard deviation of 8. What is the proportion of students who received a B grade? Okay, so let's look at that. So you'll notice here I did not include a screenshot of keystrokes. So I want you to try it on your own. So what we see here is we want to know what is the proportion of students who received a B grade. So what does that mean, right? The proportion of students who received a B grade. Well, what is a B grade? A B grade is limited between 80 and 89. Right? A B grade is limited between 80 and 89. So looking at this now, I want to go ahead and calculate this. So hit your second vars, number 2. Our lower bound here is 80. Our upper bound is 89. Our average or our mean is 72 with a standard deviation of 8. Hit enter 3 times. And what we end up seeing here is 0.1419 is the proportion of students who received a B grade. Okay, 0.1419. All right, so next thing we want to do is look at B, right? What is the probability that a randomly selected student received between a 65 and an 85? So we're trying to figure out the probability that the student received between a 65 and an 85. Putting all of this into your calculator, what you should get out is 0.7571 as our probability. Problem number C says, what is the percent, remember, words matter, very much so in statistics, what is the percent of students that failed the exam? So if we're looking for people that failed the exam, that's going to be people that made less than or equal to a 69 on the exam. So put all this data in your calculator, and what you get as the probability is 0.3538. But be mindful, am I asking you for the probability? And the answer is no, I'm not asking you for the probability. What I'm asking you for is the percent, right? And the percent, shift that decimal 2 places to the right, is 35.38%. All right, and then the last little question that we have here, and I'm actually going to go back and I'm just going to add it here to the bottom. What if I asked you this question, D, that said, out of 130 students, how many got an A? Okay, so out of 130 students, ignore this right here, by the way, how many got an A? Well, first thing that we need to do is we need to actually figure out what's the probability that someone actually got an A anyway. Okay, so the probability of getting an A are going to be the people who made greater than or equal to a 90, right? Those are the probabilities of getting an A. If you put that into your calculator with a normal CDF, you should get out 0.0122. Okay, so what that means is 0.0122 of the population that we have actually made an A. So if we have 130 total students and 0.0122 of that population made an A, that gives us about 2 students when rounded to the nearest student. So we're going to take 130 times 0.0122. That gives us, approximately, I'm going to say about 2 students. Okay, your actual number here that it spits out, your calculator, is 1.586. However, can't have half a student, right, guys? We have to have a whole student. So we're going to bump that up to the nearest whole, which is 2. All right, hope this is helpful. If you have any